Welcome to this video. In this video, I'm going to go over a quick sample problem for this week's assignment. In this problem I have a problem that's very similar to what you have for this week's assignment. So in this problem, I have a scenario in which the retailer sells products to distributors. The demand probability is 20,000 units at 15% probability, 30,000 units at 30% probability, 40,000 units at 35% probability, and 50,000 units at 20% probability. The fixed cost of production is $250,000. The per unit production cost is $600. The per unit selling price is $1,250, and the salvage value for unsold products is $750. As you can see here, I've made an Excel spreadsheet. I like to use these because once you get them set up, all you gotta do is change the numbers, and you could do all kinds of scenarios with these. It's also good to do this to kind of like check your math when you're doing these kinds of problems. So let's look at the spreadsheet that I made. On the first column B, I have the units sold, and on column C, I have the probability. The selling price, I basically linked each of these cells individually to this cell here. And if you don't know how to do that, basically you link it to a cell and you put dollar signs before each of the parts of the cell row and column. So it basically tells Excel not to change these if you copy and paste them. So if you notice here, they're all D15, so they're all going to be this. For salvage, I have it linked to this cell here, and production cost, I have it set here, and the fixed production costs, I don't have it up here because this doesn't change. It's a fixed cost. I'm not too worried about this. So what this allows me to do is if I want to change, let's say, salvage value to say $900, it automatically changes all the numbers in the, well, I'll set it back. It automatically changes all the numbers in your cell, so you don't have to worry about it. So I'm going to put this back to 750 like it was before. So when we look at the first problem you have is with an expected demand of 55,000 units for summer. So the first one, it basically asks you if you're considering production quantities of 40,000 units or 80,000 units, and assuming 90% sold and 10% salvage, what is the profit per unit? So let's say in this spreadsheet that I want to consider selling 30,000 and 40,000. We'll just do this. And over here, as you can see, I've got salvage percentage and sell percentage. So here I basically say I'm going to be selling 90% of my product and salvaging 10%. And the way that I did this is I basically have the salvage percent is something that I enter, and then the sell percentage is basically 1 minus this. So I have the sell percentage. So if I change this to say 15%, it'll automatically change 85%, and all the numbers will automatically change. So I'll change this back. So now, with the problem here, let's say if I want to figure out the 30,000 units sold, and let's say we're going to plan on salvaging 10%. Okay, well, all you have to do is basically you're going to sell all 90% of your units sold at the selling price. So basically what I have here is I have the units sold, in this case 30,000, times the percentage of that being sold, which is 90%. So this basically gives me a number, 90% of 30,000. And then I multiply that by the selling price, which gives me 33,750,000. Now the total salvage is basically the same, but with salvage. So basically I'm going to take the salvage percentage, multiply that by the units sold, then multiply this by the salvage value. The salvage value I just put in here just to make it easier for me to do the calculations. So basically the salvage value would be 10% of 30,000 times 750, which would give me this number here. And then what I do is I just add these two, because basically we have the revenue from products being sold and the amount of money that we get from salvaging our products. I didn't add a column for total revenue to include the salvage. So basically, for total profit, all I'm going to do is I'm going to take the total revenue from what we sold plus the total salvage, and I'm going to subtract this by the production cost. And I get the production cost by this cell right here. So the total production cost is basically you take this number here and you multiply it by how much it costs per unit, and don't forget to add the fixed production cost. A fixed production cost is something like one-time setups or a cost that is basically per production run. So for this fixed production cost, it's $250,000. We would add this to the total production cost. So then we would take the total revenue, which is here, add the total salvage, and then subtract the total production costs to give us our profitability, our total profit. And you can do this for all the rows. And if you have different probabilities, like let's say the percentage of salvage is different between these for whatever reasons. I can't think of any off the top of my head, but let's say there was, you can manipulate this spreadsheet as much as you want. And if you wanted to, you could add another column that has the total of all of these and then subtract it from here. I just didn't do that because I guess I was kind of in a hurry and I just didn't feel the need to do that. But you could, if you want to add more detail, you can always add the cells where it adds these two columns here, and then it subtracts the total production cost. So you can even put the production costs over here, just copy that cell over here, and then just have it bring the cell here. If you have any questions over how to do an Excel spreadsheet like this, how I did it, say something in the classroom, and I'll be more than happy to make this spreadsheet available, and I'll even go over it in class if need be. Now, for question 2, basically the question in the classroom is the manufacturer is considering production quantities of 40,000 units or 80,000 units. And each of these unit levels has different levels of salvage. So which is the profit per unit, which option would you select and why? And this is where the spreadsheet comes in handy. So let's say here we have 30,000 units and 40,000. Let's say the salvage percentage is 25% for 30,000. And actually, let's make this 15%. And let's say the salvage percentage is 20 for 40,000. Maybe there's more risk in trying to sell 40,000. So once we do that, this spreadsheet would automatically calculate all of our cells to tell us what the total profitability is. And what we can see here is the total profitability is still high at 40,000. Now let's say if we increase this to salvage to 40%, let's say 40%. Well, now we've almost broken even. So if you want to see how this works, you can always manipulate the salvage value. If you drop the salvage value to say 600, you're going to see that the break-even points are going to be even greater. So basically, in this vein of thinking, the closer the salvage value is to the production cost per each unit, the more likely it is that you're going to go underneath the break-even point, because if the salvage value doesn't cover the cost of manufacturing, then there's a lot of risk involved, and there's no guaranteed way in which you can get all of your money back, if that makes sense. So if you get a chance, play with this if you want. I'm going to put this back to 750. If you make this spreadsheet, you can play around with these numbers here. So this is where manufacturers tend to crunch the numbers to see how much they're willing to make. If the salvage value is higher than the manufacturing cost, then yeah, they're like, well, we are guaranteed that we're going to at least break even or at least make more. Okay. If that salvage value is less than manufacturing cost, at that point there's a risk involved where they may be less willing to add more. Sorry about that. If the salvage value is less than the production cost per unit, then there's going to be a point in which they're going to be less willing to make more product without a guarantee of it being sold. And that's when sometimes a distributor or a retailer may have to incentivize them by saying, hey, for every, like let's say if we're dealing with 30,000 here, I'm just going to highlight this. Let's say for every unit over 30,000, we may give you a salvage value of $800 guaranteed. So they say, okay, well, at least if there's a good chance of 30,000 units being sold, then they may be more likely to take on more risk. So this is how you can play with the spreadsheet to determine where the break-even points are and where the profitability is. I like to make these spreadsheets because it's much easier to see what's happening in the supply chain. I actually make spreadsheets like this every time that I do these kinds of exercises. Now, question 3 says, with an expected demand of 55,000 units for the summer, a maximum demand of 80,000 units for the summer, and a 2-week lead time, calculate the amount of safety stock needed to cover demand. So there are several different safety stock equations, and here's 2 of the most popular ones that are used. The first one, courtesy of TradeGecko, it's a website they got this nice graphic from. Basically, you take the maximum daily usage times the maximum lead time in days minus the average daily usage times the average lead time in days. So the main thing to remember is that when you deal with safety stock equations, make sure that you use the same unit of measure. So in this case, it's days. You can use weeks, you can use months. Usually people use days, but in this case, the units that they use is weeks. Basically, so there's basically 2 numbers that you really need to have here. You have the expected demand, and you have to convert that into weeks. So let's say, I'm just going to make up a quick problem. Let's say I've got 40,000 and 50,000. I'm just going to make something up real quick. If I want to, if these are 3-month periods, if I want to divide this into months, I would take this cell, divide it by 3, and this number would be the demand per month. Okay, I could do the same. I just drag the cell down. Whoops, control. Sorry about that. I just want to copy that cell down. So now at this point, this is a month, per month. Now we need it by weeks. I'm just going to put it up here, per month, and then we're going to do per week. And since we're dealing with weeks, basically, usually there's 4 weeks per month as a calculation. Obviously, most months have more than 4 weeks. But for this calculation, we're just going to go divide each of these numbers by 4. Divided by 4. So I'm going to carry this down. So now 50,000 is 4,166.66 per week. Once again, you can always round up everything else. But for our purposes, this is fine. So now we have the average, we have the weekly usage. This is the weekly usage. Now, in these problems, we assume a constant demand. So the average weekly usage would basically be the same for each week, okay? Because once again, if you go from 10 to 0 and you add them all up and you divide them, it's always the middle. So if we plan on using 4,166.66 or 4,167, we can always put 4,167. We'll just round up 3,333, whatever. So if this is going to be the demand per week and our demand is constant, then that's going to be your average. So now you multiply this by the number of weeks. Now the lead time is 2 weeks. So now we just put up here lead time. And basically, you're basically going to take this one times 2. And this times 2. And basically, this is how much we're going to need to have. This is basically 2 weeks worth of stock. So our maximum weekly usage is 50,000 times the lead time. So this is the first part here. So basically, the first part of the equation would be this here. So equals that. Whoops, sorry. I'm just going to put a symbol equals in there. And then we're going to go say, this is the maximum daily usage. and we're going to subtract the average daily usage. So this is the average daily usage in this period would be this one here. So we would go equals this. So we would go the maximum usage, maximum daily usage times the lead time in days, or in the weeks in this case, subtracted by the average daily usage in weeks, or times average lead time. So basically, since we're measuring it in weeks, this is the weekly multiplied by the 2-week lead time. So that's 666. So then the safety stock in this equation would be 1,668. So basically, in this case, you would need 1,668 units as a safety stock, assuming that we want to always have 40,000 available, and we're going to have this much stock available for every 2 weeks to make sure that we have enough stock in case we hit this 50,000. Now, if you go into the safety stock, the basic rule of thumb is when you go into the safety stock, the next time you order the demand for the following period plus the replenishment of the safety stock. So you want to always keep the safety stock in place. And this is where variability comes in. A less variable supply chain will have less safety stock required, which saves you a lot of money. So if you have a choice between longer lead times and less variability, less variability is usually the best way to go. Now, this is the other safety stock. This is another safety stock equation that is pretty popular. Now, I just want to show this because you'll probably see this a lot when you're doing the safety stock equations. I'm not sure if the book goes into this one in very much detail, but I just want to provide it here and go over each of the variables. This safety stock equation is used when you have a z-score. So the z-score we're talking about is your service level. There's a service level C-score that basically corresponds with the percentage of people that you want to have a product. So if your Z-score, if you want 95% service level, then your C-score is basically based upon the probability within, the sigma probability that you will have to, that will occur. There's a chart. There's a Z-score chart that's available on the internet. They're all over the place. And Z-score is used for more than just service level. It's used for many statistical calculations. But the Z-score is a statistical probability that you will maintain a certain level of customer satisfaction. So like 95%, 98%. Usually the standard I've seen is about 95%. Sometimes it's higher. Like for instance, if you may have a customer that always wants a product, then you have no choice but to have like 100% Z-score, which is very high, obviously. But if you have a customer that's willing to wait, okay, you might want to go down to 90. I've rarely seen it go below 85, but usually 90, 95 is the average I've seen. So PC is the performance cycle, which is another term for total lead time. So you just put in there total lead times as PC, divided by the time increment used for calculating the standard deviation of demand. So when you calculate your demand variability, you're going to have a standard deviation, and that's what the demand variability is. And this is calculated based upon a certain period of time. So if you have your period of time of, say, 6 months, you may have a weekly standard deviation over a 6-month period, which would be roughly 24 weeks. Then you get the standard deviation of that. Now, in general, obviously, the more data you have, the more accurate the standard deviation is. But you have to be careful, because if you put in too much previous performance, you'll get data that may not still be indicative of current performance. Like for instance, let's say you release a brand new product and the demand is very high, and all of a sudden the demand stabilizes because it's just not as popular anymore. If you include all of that demand, your your standard deviation will be artificially high because you included the time that the product was just released. This happens more often than not, and I've seen several instances where they accidentally include this in long-term forecasting. But just realize that when you look at any data for your standard deviation of demand, kind of sanity check it to make sure that the data is as representative of existing demand demographics as possible. And then you multiply it by the standard deviation of demand. So if your standard deviation of demand it is a certain sigma, and then you would multiply that standard deviation. Actually, I'm sorry, standard deviation is not a sigma. So if your standard deviation is, say, 7 units, then you would multiply all of that by 7. So basically, you're creating a number that includes your service level. It includes the standard deviation of the demand. Then it includes a factor that is the performance cycle divided by the time increment that the standard deviation of demand is used for. And then that'll give you a safety stock calculation. Now, once again, I highly recommend that you use data that's very representative of the current conditions that your product is subjected to in the market. Once again, if you have now, sometimes with new products, they may take a similar product and use that demand forecasting to determine a sort of safety stock for a new product. That can be the case if the product is very similar and the type of customer is very similar and the demographics are similar and the locations are similar. As long as there is a lot of similarity between products, you can do that. But just do the best you can. Just realize that there are assumptions into these safety stock calculations. Okay, so please feel free to provide any comments in the classroom or on the YouTube channel if you have any questions over this. I went through the spreadsheets as much as I could. I didn't go in depth with all the different calculations up in the spreadsheet, but I'll go through them real quick one more time. So units sold is basically from the data that's provided. Probability is the same, selling price is the same, salvage same, production costs. Total production cost is, you see up here, it is the units sold times the production cost plus the fixed production cost. So basically, the total production cost is the units sold multiplied by production costs, then add the fixed production cost. And now the total revenue is very similar. You take a unit sold, multiply it by the selling price, and that's the number you get there. And total profit's very simple. You take the total revenue minus the total product cost, and that's the number that you get. Profit per unit's very simple again. Take the total profit divided by number of units sold. Very simple. And then on this case here, total revenue, when we do the salvage value and salvage cost, the salvage value, basically the total revenue will basically be the amount that you sell, okay, the percentage of the products that you sell. So this number times units sold, and you multiply that by the selling price, and this is the total revenue here. Total salvage is the salvage percent multiplied by the total number of units sold multiplied by the salvage value, which is either here or down here. Once again, you could get rid of this column and just have everything linked to the cell. I like to do this so it's in the event that I have different salvage levels for different types of levels, but you can do whatever you want. And then total profit, now I don't show this, but basically I take the total revenue, add the total salvage, and I subtract the total production cost from it to give me my total profit. So that's a quick rundown of all the cells that I've used so that you can calculate, create this quick spreadsheet to calculate whatever you want for all these numbers. I would take the time out to look at all the variables and get used to what each of these cells is doing, so that when you do it in the future and you understand what's going on in the background, it makes it easier to remember. And this is just a quick lead time. If I basically break down, this is a quick safety stock calculation where basically take the monthly demand, break it down into the weekly demand because I've got weekly lead time. And then I basically, with a 2-week lead time, I basically take 2 weeks of the maximum minus the 2 weeks, 2 weeks of the maximum, subtract by the 2 weeks of the normal daily, average daily usage. And then that subtracted gives you 1,668 units that you will need to have the safety stock. This is a very general safety stock calculation. It works for very basic inventory calculations. For ones in which you have a service level and you have an actual demand variability, which I usually like to recommend for more long-term and more products that are very variable. If you have a customer that always orders the same products all the time and your demand is relatively flat, you may be able to get away with this top one here. But for products where you may have like a lot of different customers or a lot of different markets and the demand may be fluctuating, go ahead and use this one, get the Z-score, which is the service level, which is usually provided by management, and the standard deviation of demand, which is your demand variability. Once again, if there's any questions, please feel free to put any comments in the YouTube channel or in the classroom, and I will answer them as soon as I get them. Thank you very much for your time. I greatly appreciate it.